Hello all, so in this video we will see two problems, merge interval and insert interval. So first problem is easy, and insert interval we'll see a key difference between these two, that why even though our mind thinks a bit that they both can be solved using the same logic, but there is a bit of a difference, and that's why I have made this video covering both the topics in the same lecture. So let's see what we can do in both the problems. So let's begin with the easy one, that we are given an array of intervals, and so each point in the array is a list, and it has a start point as well as the end point. And what we have to do is we have to check if there is any merging that is possible, or because of the overlap. So you can see 1, 3 and 2, 6. So I have drawn the similar thing, that you can see 1, 3 and 2 to 6 is this one. And we know that there is an overlap. This much is the overlap, right, between these two intervals. So you can clearly see the overlap. And what we have to do, since there is an overlap, we have to just simply merge it and make it entire from 1 to 6. Okay. So, and you can see other intervals like 8 to 10 and 15 to 18, there is no overlap. So we will have them as it is. And that's why our answer is, you can see the first one is merged, and then rest two, since they are not overlapping, we will put them into the answer as it is. So, and one more thing, that even though there is a border, like you can see it starts from 4 and the previous one finishes at 4, and they are also considered overlapping. Okay, so it should be strictly greater than, even if it's equal to, then still there is an overlap and we have to return the overlapped interval. So that is what we have to do. Let's build a logic. So logic is a bit simple, that what we will check something like this, that if my let me take some different color, that if my starting of the next interval is less than the ending of the previous one, right? So, or even equals to, so not less than but even equals to. So let me write that if my start of next interval is less than or even equals to the end of previous interval, then we can say that there is an overlap. But there is a big condition that we haven't checked, that here all the intervals are sorted by their starting interval, or the number. You can see 1, 2, 8 and 10. Okay, but what if this is not the case? Then we can't check directly like this, right? We need all of them to be sorted, and the question doesn't mention anything about sorted or not sorted. So we have to consider worst case scenario, and there is a possibility that in our hidden test cases there is an array or of intervals where these things are not sorted. Okay, here as well they are sorted, we are lucky, but it's not mentioned anywhere. And that's why first thing what we have to do is, even though we are given a sorted array, we will sort them. Okay, so the first thing first, that we will sort. So, and I'll store after sorting into the same variable, so I'm not using any extra space. So I'm using sorted function in Python, and I'll use key as the first one, so x of 0, and by default it's ascending, so we don't have to mention reverse equals to true or false. So by default is ascending, and our sorting is done. So there is a difference between sorted and sort function. So you can just ask ChatGPT, that will be your homework, that how the sorted and list.sort or intervals.sort, in this case there's a bit of a difference. It's easy, just go through it. So let's continue. Let's say this is our final list, which we call it merged, that we will return. Now, as we have seen, that what we have to do in order to check, we need first previous interval, right? And then we have to check that with the next one. So what we will do, we will store our first interval into a variable called previous. I will call it intervals of 0 as previous. So we have stored successfully 1, 3 into the previous. Now I'll iterate. Okay, so let's iterate. So I will iterate, but now from first position, because 0th index is already stored in previous, until my length of intervals. And what was our condition? Our condition was that if my, let's check again, what was the condition? That if my starting of the next interval, so right now we are starting from first index, so this is our current, or you can say next, right? And this is our previous, which is 1,3. So if this starting, so right now we are at first index because we are starting from first, so we have to check if the starting, so we have to check starting means 0. If the starting is less than or equals to ending of the previous, so previous ending, which is not first, which is the first index, not the 0th index. If this is the case, then we can say there is an overlap. Let me write that. Condition for overlap. So there is an overlap. So what we will do, we have to merge. And in order to merge, at the end, we know that after merging, we will get 1 and 6. So what we have to do, we have to update our previous, because previous is, why previous? Like you can also take like minimum of first index and maximum of second index. That can also be done, and we will get 1 and 6. Okay, but let's be a bit optimistic, and what we can do is, we already know that previous is already having 1, right? And which we need, so we'll just modify the last index of previous. Okay, so we'll just modify. As I said, you can do min and max thing, but just to be a bit of a good programmer, because we already have them 1, so we don't need to find that min. Just we have to update the max or the first position of previous. So what it will be, it will be the same maximum of the so right now what my previous is this, right? So maximum between 3 and 6. So how I'll write it, it will be intervals of the current IDX where we are and its first position, which is 6. So right now what happened is that, let me write that in on the whiteboard, that what happened, I'll write the previous every time here. Right now my previous, so currently my previous was, at the starting it was 1 3. Now we have updated it, and now it becomes 1 and 6. Okay, so this is what our previous is right now. And also let me have our merged, so let's have some space where we will add our answer in our merge list. So currently we haven't added anything. Okay, and this is our previous, which is 1 6 as of now. Now what we will do, we know that this is being done, right? Now in our next for loop, what will happen, our current variable will be this. Okay, so and the previous should be this, right? So we have to update previous every time. Okay, so we will do that first. And also when there is no overlap, then what we have to do, for example, let's say that here it was 4. Okay, then there is no overlap. Then what we have to do, our this condition is not satisfied. Then what we have to do, we have to first add this one, right, which was our previous. So we will first add our previous to merged. So now I am appending my previous to merged. And as I said, that after we append this, what we have to do, now this will be our previous and this will be our current one, right? So every time we have to update previous. So let's update previous, and previous will be whatever is the current one. So I'll just use this and delete the index. Okay, So that's what happened. This is the else part. Okay, but I'm not writing that in our variables, right? Because we have considered the else part, which is not true in this case as of now, right? Because we have our overlap, so we are not going to do the else part. But I have just explained the scenario that what we do when we go to the else part. So every time we have to update the previous, correct? Now until now what happened is that we have merged this. Now my previous is 1.6. Okay, previous is 1.6, and we haven't encountered this else condition. We just used this condition and we updated our previous. So until now, this is the case that my previous is 1.6 and my merged is empty. Until now, it's empty. Now let's move further. That now we will go back again to this loop, correct? And now this will be my ID. My ID will be 2 IDX, I mean, and this will be my, and my previous will be 1 and 6 because we have merged in our condition. My previous is 1 and 6. Now we will check between 1 and 6 and 8 and 10. So let me write that. It's better just to explain that what we are going to do now is that my previous, as we know, it's 1 and 6, and my current is 8 and 10, right? So now we will see that there is no overlap. You can see there is no overlap, and that's what we needed. That's what we discussed, that what happens when we have 4 here, right? Then there will be no overlap. And the same thing happened, that between 1, 6 and 8, 10, there is no overlap. So now we will hit this condition. So what we will do, we will append our merged with previous. So sorry, now we will append our merged with previous, and my previous is 1.6. So now my 1.6 is inside. Now what we will do is, now my previous is being appended into the merge, and now my previous is updated, right? Now my previous becomes this, okay, and my current will become this, okay, when we hit the for loop, like next iteration of the for loop. So let me also write that now my previous is updated, and what it will be 8 and 10, 8 comma 10, and my next will be this one, which is 15 18, correct? Now we will see again that what's my previous is 8 10, and this is 15 18. Again, this condition is not satisfied. What we will do, we'll again append into the merge what our previous, and we know that what's our previous, it's 8 10. So we will write 8 10, correct? So now this is also done, and again now we will update our previous, and what will be our previous will be 15 18, correct? Now we are out of this for loop, correct? Because we are done with all the elements, so this will come out of the for loop, okay? But still we haven't updated everything yet, right? We are still left with 15 18, right? At least. And what's that 15 18? 15 18 will be our previous, correct? Because this will become our previous, right? This became our previous here when we appended this 15 18, this 8 10. When we appended 8 10, we changed our previous to 15 18, right? But we didn't get the chance to append it into the merged. So we need one more merge after the end of the for loop, okay? So we will need one more append, we'll need one more append into the merge after the end of the for loop, and it will be again the previous, which will be now 15 18, correct? And at the end we return our merged, and let's see, yeah, it's working. Let's submit. Yeah, it's working. Right. You can see our time complexity will be n log n because we are using sorting. That's why. So exit it will be, and we are not using any extra space, but still it's showing of n space. I think we are not using it any extra space, or at least we are using, yeah, we are using this to store priv. That's why, maybe because our input and output are not considered when we check this space complexities. So what our exit time will be, let's discuss from the time. So our exit time will be, this will take n log n to sort, and then we are going through all of them, right? So we will say that we are taking extra O of n because we are going through each and every interval, right? We have total n intervals, so we can say that O of n log n plus O of n, but you know that higher terms matter, so it will be O of n log n. And for space, it's O of, because for example, let's say we have just one interval, right? Then we have to store that in previous as a list. So that's why this extra space of list, that's why it's considered as O of n. That's what I think. So that's about this. And even I have premium, so in the editorial you can check that if we can sort in place, we don't need extra space, although sorting itself takes log n space, otherwise we must allocate linear. Yeah, okay, so that's what they are saying in the sorting case, and this is our brute force way. Connected components, okay, that's out of the scope of this lecture. We will see this in one of our next videos, in the future videos. So that's about this merge interval. Now let's see about insert intervals. A really inverse problem to this, just inverse. Okay, so here it's the code, but let me remove that so that it's easy, so that we can write it again. Now what this problem says, let's see that.